Hey, fellow mathers! Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or memorizing facts, but it's about thinking and reasoning, about creating and using mental relationships. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
All right, y'all. In this episode, this week, we are going to do some higher math.
Dun, dun, dun.
Just for you all.
Woo! All right. And Kim's a little excited. Scared. Excited about today. We were kind of talking a little bit about how this episode was going to go. And Kim was like, here we go.
This is not my jam, but I'm willing. I'm going to learn and grow.
Yes. It's not your jam yet. You're actually so much further than you think you are on a landscape of learning. Lots of fun. So y'all take a deep breath, get a pencil and a paper for this one. You're going to want to write some stuff down if just because I'm crazy. And so you should write stuff down. But you might want to look at some things. You might want to pause this episode a little bit after you look at some things. If you're a high school math teacher, okay, maybe not, but maybe. So just be aware. Here we go. Today we're going to talk about writing the equation of a line, given some information. So if I give you a point and a slope, write the equation of a line. If I give you 2 points, write the equation of a line that contains those 2 points. I could describe the line. I could say it's vertical, and it goes through this point. Lots of different things that I could say, or really just a few sets of things that we typically say, that then we would expect a student to write the equation of a line. Okay. Uncle, right? I cry uncle. Of all the things we've talked about, this surely we have to have formulas for this, right? Surely we have to have step-by-step procedures. You can't reason about writing the equation of a line. Or can you? What would it be like to work with kids' intuition to help them reason and find strategy for writing the equation of a line? Let's do that. So let me just paint a picture. When I travel around and I look at teachers, classrooms, students all across the nation, when I've looked at kids writing the equation of a line, I see often a very particular thing happening. Say kids are finding the slope between 2 points, finding the rate of change between 2 points. I often see this. I see minus, divide. I see kids finding the rise, the run, and then dividing, right? They're going to subtract, and then they're going to divide the rise divided by the run, rise over run. I see that a lot. And it becomes this very procedural thing to do where they sort of do that, and then they plug that into a formula, and then they do a bunch of combining like terms and messing around, and then they come up with like y equals mx plus b, or maybe the standard form ax plus b y equals c, like maybe like all that. And if you guys don't teach higher math right now, you're like, all the alphabet soup, like all this stuff that's happening. I see a lot of procedures and step-by-step stuff. One day I was doing a workshop with teachers in Texas. So I live in Texas. I was doing a lot of work with teachers in Texas early in my career as I was a math teacher educator. And I had already figured out a few ways of helping teachers parse out how we can use intuition to solve or to write the equation of a line. But I had not developed a particular strategy that I want to work on today on the podcast yet. I hadn't developed it yet. And so I handed out some points to the teachers, and I was having them do some things. And we're going to talk actually about that strategy a little bit more next week. But they were just looking at a set of points, and they were supposed to write the equation of a line. And all of a sudden, I was circulating in the room, and we had a huge group. I do not like to do workshops this big. In fact, this might have been the last that big workshop I did, because it was put on by the state, and they forced it. And I don't know, I had like 50 people in the room, just me, 50 in a huge room. It was terrible. So I'm wandering around. I like to do 35. 35 is it's a great in person. It's not bad on Zoom. 35 is pretty good. I don't know why, but that's less than 35 can actually not be so, especially less than 20. Anyway, you don't care. So I'm doing this big group. I think it was like 75 people in the room. I'm wandering around, not wandering. I'm circulating, and I'm purposely watching what people are doing with the set of points that I'd given them. Their job is to write the equation of the line. This one gal, I wish I remembered her name. She goes, "Don't look over my shoulder." And I was like, "Oh, okay. All right. What, do you want to tell me what you're thinking about?" "No." And I was like, "Okay." She goes, "I'm not math." And then she goes into this whole like, "I'm science. I don't do math. I whatever." And all these disclaimers about why I should not be looking at her work. And I said, "Okay, but I'm actually curious. You have an equation written there. How'd you do that? Like, were you just following steps and not kind of the way we were talking about? Like, what were you doing?" And she goes, it just jumped out at me. Ooh, I got intrigued. Anytime somebody tells me that their intuition was involved, that something pinged for them, I'm interested, right? I'm thinking about that, and I'm thinking about that a lot, right, in that moment. So hey, I'd be really curious what you were just thinking about to find the equation of the line. And she said, "Pam, I just see it." I said, "What do you just see?" And she goes, "Look at them. If you add those together, no, if you subtract them, I get 1 every time. So the equation's just x minus y equals 1. I said, "I'm sorry, what?" She goes, "Go walk away. I'm not math, whatever, blah, blah, blah." And I said, no. What did you just say? And she said, I had given her 4 points. And she said, if you look at all of the x values, and you, from one of the x values, you subtract its y value, every time I get 1. So I just wrote the equation x minus y equals 1. I said, "Say that again?" Y'all, it was so new to me to like look for patterns in the table of values. So she had 4 points. She looked at the x values. She looked at the y values. If given one of the x values, when she subtracted the y value, so like if she had 2 as the x value and she had 1 as the y value, she said 2 minus 1 is 1. And I was like, "Well, that's true." And she goes, "Okay, but look at one of the other values. So if it was 6 was the x value and 5 was the y value," she said, "Look, 6 minus 5 is 1. So every x minus every one of these y's gives me 1. So I just wrote the equation x minus y equals 1. To which I said, "Can you do that?" I was the sort of Z perspective growing up. I was the one who memorized all the things and did all the steps. I was hooked. I was fascinated that there might be sets of points that I could find a pattern, that I could just write down that pattern and have the equation of a line. Kim.
Yeah.
Can we work on that today a little bit?
Sure. Let's do it.
I wondered in that moment, could we teach that? Could we teach that strategy of looking at the values, finding a pattern, and then just recording that pattern sort of generally?
Okay.
Okay. So I'm going to give you, all right, listeners, Kim, I'm going to give you guys a set of points. I'm going to give you all a set of points, and then I'm going to pause, and I'm going to suggest that you pause and then think to yourself, what are the patterns that you see in that set of points? Do you see any patterns? Specifically, think about, if I gave you any x value, could you do something to that x value and tell me what the y would be so that it would follow the same pattern as the 4 points that I'm going to give you?
Okay.
You might even graph the points just to like sort of prove to yourself that they're on the same line. However, caution, if you are a high school math teacher, you might not want to do that, because if you graph those points, you might not be able to stay out of a rote memorized way of writing the equation of a line. So if you've got some rote memorized way of writing the equation of a line, I'm going to encourage you to maybe not do that, to see if there's some patterns that you could find, and maybe don't graph them if you already have a rote. Go ahead if you want to, but maybe if you don't want the surprise spoiled, maybe don't do that. But anybody who doesn't have that down, you don't have a rote memorized procedure down to write the equation of a line, maybe just like what patterns do you see, maybe even graph the points and see kind of what they look like. Do they line on the same line? And what does that mean to you? And then come back. All right, Kim, here is the first set of points. So I'm going to give you 4 points. So the first point is 0, -2. So I would write that as parentheses 0, comma, -2 parentheses, right? It's points. An order pair, 0, -2. The second point is 1, -1.
Okay.
The third point is 2, 0. And the last point is 3, 1.
Okay.
So y'all pause. Let me just say it again. 0, -2, 1, -1, 2, 0, 3, 1. Pause the recording. Go see what patterns you can find. Maybe graph the points. Come on back. All right. Hopefully people paused a little bit. Okay, so Kim, what patterns do you see? Just like first thing that comes to you, what patterns do you see?
I noticed that the X values increase by 1.
Sure enough.
And the Y values also increase by 1.
Sure enough. Like they're going up. Now they're different, right? There's not the same, but they're all going up by 1. Okay, cool. Did you notice any other patterns?
Yes. So I also looked, I don't know if you say it this way, but kind of between the X and Y value.
Uh-huh.
And I noticed that
like from X to Y? Uh-huh.
Yeah. So from X to Y is a decrease of 2.
Wait, what do you mean?
So so I'm looking at the series of points that you just gave us, and I started kind of from the bottom up, and I said how do I get from 3 to 1? And that's subtract 2. How do I get from 2 to 0? That's subtract 2. How do I get from 1 to -1? That's subtract 2. And to get from 0 to -2, that's subtract 2.
So I hear you saying that 3, 1 was actually kind of helpful as you looked between the X and Y. You said to yourself, well, I know that relationship. That's just -2. I wonder if it works for the other problems. I kind of heard you.
Yes.
Like, I wonder.
Absolutely.
And whoa, it did. You're like, yeah, sweet. It did. So I might record your thinking. I might make that visible by saying you took an X value, you subtracted 2. So I would write down X, subtract 2. And you said that every time that equaled Y.
Yes.
So I would write down X subtract 2 equals Y. Do you agree?
Okay. Yep.
Yeah. And you just wrote the equation of the line that contains those points.
Okay.
I don't know if you could hear the drum roll there a little bit.
All right.
Now, just from noticing a pattern, you were able to hey, I found a pattern. It worked for all the points. And so I'm just going to generalize that, give you any X value. Like, what if I gave you 4, Kim, right now? If I gave you 4, what would you do?
I would say that the X is 4 and the Y is 2.
Because
4 minus 2 is 2.
Yeah, so maybe that's not the best point because we got too many 2s in there. So what if I give you 5? If I said the X value is 5, what would the Y
point
be?
would be 5, 3. 5,
because you're saying X subtract 2 is always going to give you the Y value, and there you go. So I could literally give you 1 million. 1 million is the X value, and you could say that the Y value would be
998,000.
Oh,
I did that. I started to write it down. 999,998.
There we go. That was fun.
It's hilarious.
That's what I would typically do. Okay, cool. So you've now found a pattern that works for any X value, and that is what the equation of a line means. It means this is a pattern that if I give you any X value, you can tell me the Y value based on this pattern. That's how we describe that set of ordered pairs, that set of points that make up that line.
Okay.
So ready for the next one?
Sure.
All right, here we go. 4 points again.
Okay.
And you're going to look for patterns and try to tell me if I give you any X, what would the Y value be? Okay, first point, -1, 1. So -1, comma 1. Next point, 0, 0. 1, -1. 2, -2. I'll say them really fast. -1, 1, 0, 0. 1, -1. 2, -2. All right, everybody, pause the recording. Pause the podcast. Go see what patterns you can find. Come on back when you're ready. All right. Hopefully they pause the recording. I feel funny because I feel like I should pause longer.
Yeah,
Okay,
because I don't have a huge pause.
Oh, that doesn't give you any pause, does it?
It's okay. It's
Kim's
all right.
like, Pam, give me some time here.
Well, okay, so can I tell you the first thing that I thought about?
Yes, please.
Because I was trying to think what this would look like on a graph. And so
okay.
I like the origin, right? The
That's nice. Yep. 0 zeros in there.
But so when I was looking at the first and the third points that you gave me, I was like, ooh, those are opposites. So it
Wait, those. So those are adjectives. What's opposites?
Sorry, the -1, 1 and the 1, -1.
I just said adjective and I meant pronoun. Okay, so the x value is opposite of the y value. Is that what you mean?
Mm-hmm.
Is that true for all of the points?
Mm-hmm.
Okay, so I might record your thinking that the y value is equals the opposite negative of the x value. I might write that as y equals negative x, or the opposite of x.
Mm-hmm.
Because you're telling me that the y value is always opposite the x value. So I give you any x value, take the opposite sign, I would get the y value.
Yeah.
And that's the equation of that line. Y equals negative x, or the opposite of x.
Huh.
No way, right?
Yeah.
And let me just pull back on some prior knowledge that you might have. I think you know what the line y equals x looks like, right?
Mm-hmm.
It's that 45-degree line.
Mm-hmm.
If I were to graph it, that's the line y equals x. You and I have done some work that I think you know that parent function. So what if I just said, Kim, that y equals x, I need all the opposites now of the y values. Every time you had a positive y value, when you went over to an x value, every time you had a positive y value, I need now, don't graph the positive y value, graph at that x value, graph the negative y value. I wish you could see my hand, because I was like putting a point up in the first quadrant, and I was like, but not that positive y value, and I was like reflecting down into the fourth quadrant to stick it down there. And so now, but back in the, let's go in the normal y equals x, that's normally in the third quadrant, right? It's down there, that 45-degree angle, down there, negative third quadrant.
Mm-hmm. Mm-hmm.
But now those y values shouldn't be negative, because I need the opposite of them. I need them to be, pop them up to the second quadrant. I need them to be positive. Now, y'all, if you haven't heard quadrants for a while and everything, okay, sorry. But hopefully all of my graphing, people that graph more often, that made a little bit of sense, that we can sort of talk through why that reflection's happening. All right, let's do another one. Here we go. I'm going to give you 4 points. And -2, 3, -1, 2, 0, 1, 1, 0.
Okay, they're gonna pause.
Oh yeah, sorry.
And I'm gonna pause.
Sorry, I was pausing. Pause the recording. All right. So Kim's gonna pause. Oh, so do you want us to really pause longer here, and Craig can cut out the?
No, it's okay.
Okay. Craig's our editor, everybody. So if he cuts dumb things out, we're not gonna have him cut this out. We're letting him think.
It's live. Live math.
Yeah, Kim's like, stop talking, Pam, so I can think.
I do that a lot.
All right, I'm letting Kim think.
Okay.
Letting Kim think. Okay, what do you notice?
All right, I find that now I'm not really necessarily looking from the first point down to the second point, down to the third, down to the fourth, like I did the first time.
Okay.
Because I'm recognizing that you want me to think about how to get from X to Y. So that original thing I did has not helped me. So I want to first look from 0 to 1, and I want to call it +1. But then that's not really helpful so x plus 1, but that's not really helpful for the other points.
Okay.
I'm looking at -1 to 2.
Mm-hmm.
And how can I get from -1 to 2? And I'm thinking that the only way to make something work for both of those points is to consider the opposite of x.
Yeah, it's actually interesting. When you said -1 to 2, I thought, well, you could add 3. And
yeah, I did. But
I'm assuming you did that and discounted it because it didn't work for any of the other points. Yeah, so I just wanted to bring that out.
Sorry, yeah.
So then you said, for me to get from a negative value to a positive value, that maybe there might be some of that opposite stuff going on. And we could have mentioned that in the problem before, when we had y equals the opposite of x, that we had this sort of switchy thing happening between the x's and the y's. We had kind of had this negative positive switch happening. And so there was that y equals the opposite of x in the problem before. So in this problem, you also might have some opposite of X going on.
Yeah. Yeah. And so, it's interesting because I feel like the zeros are actually tripping me up a little bit. If I would have focused on
Mm.
the first two,
Mm-hmm.
then it's definitely the opposite of X plus 1. Let me confirm. Opposite of X plus 1.
So you
Opposite
just
of
tried
X.
it on the first two
Yep, I
problems.
sure did.
Yeah. So like when you looked at
Opposite of X
negative
plus
2,
1.
3, did I just interrupt you?
Nope,
Sorry.
go ahead. I'm good.
When you looked at negative 2, 3, you said, well, if I looked at the opposite of negative 2, that's 2.
Mm-hmm.
Well, to get from 2 to 3, that's just plus 1.
Yep.
Let's see if it works on the next one. Opposite of negative 1 is 1.
Yep.
1 plus 1 is
One is
also
2.
Bam! And then you can go check to see if it works on the 0. And often zeros and ones are funky.
Okay.
Often zeros and ones are a little, they behave a little differently because of the identity properties. And so that's interesting. Yeah, those can absolutely trip you up.
Yeah, I
Cool.
was drawn to the 0 at first, but now I'm
Sure. So I would record your thinking as I can get any y value, y equals the opposite of X. So I would write negative X and then add 1 plus 1. So the equation line could be y equals the opposite of X plus 1. Totally cool. If I may share a different strategy for the same problem.
Okay.
I wish, this is our unnamed gal at our science gal at the workshop. This is the strategy she used. So she looked actually at the 0 and the 1. Even though you found them problematic, she was like, okay, if I look at the point 0, 1 and I look at the point 1, 0, both times if I add those together, I get 1. Like 0 plus 1 is 1.
Okay.
1 plus 0 is 1. And then she tried that in the other points. So is negative 2 plus 3 1? Yep. How about negative 1 plus 2? 1. Yep. So I would record that thinking as take any X value, add it to the Y values, and I always get 1. So X plus Y equals 1. Now, wait a minute. We can't have two equations of lines for the same set of points. Well, Kim came up with y equals the opposite of X plus 1. And my science gal would have come up with X plus Y equals 1. And those are equivalent. Like if you move some variables around, then it's the same equation. One of them is in slope-intercept form and one of them is in standard form. But it's the same. Whoa. In fact, my science gal was just coming up with equations of lines in standard form. That's interesting. How many times have we messed with standard form as sort of a last minute thing that we do? It's kind of usually the last thing in a chapter. We don't really do a lot with it except for take the other forms and turn it into standard form. Like that's interesting that we could actually have a strategy that a student uses, kind of motivate. Check it out. This form that we just came up with, that's called standard form. All right, y'all. So I'm going to encourage you that there are ways that we can teach strategy even in lots of higher math things. Now, I know that we did one that's not going to work for all equations of lines, but I would ask you to consider, like if I give you any set of points, you're not necessarily going to be able to recognize the relationships like we just did. I obviously gave you sets of points that were fairly easy to recognize the relationships, but that doesn't mean that they don't exist, that strategy isn't out there. In fact, I would love to hear from you on social media. If you are the secondary teacher who's like, oh, actually, I do that all the time. Like I look at the points and first I see if something just jumps out at me. And if it doesn't, then I go ahead and do the, whatever else. Well, y'all, that's a strategy. That's a strategy worth teaching. We can teach that to students. We can teach to students that they can let their intuition drive which strategy they choose. And if they have a strategy that's more efficient, they can choose that one first before they then go to anything that's less efficient, the not using so much the stuff that pings for them, that we can actually think and reason. You can see patterns, not just doing that subtract, divide kind of procedural stuff to find the slope of the line and then put it in a formula and do all that. We don't have to do that. One of the things that I wanted to point out is as Kim was doing that, notice that she was not just thinking functionally, though she was also thinking multiplicatively and additively. That functionally depends. Her being able to see those patterns had a lot to do with the fact that she was already thinking both additively and multiplicatively. we didn't just, she's also thinking proportionally. We just didn't see that here. But because she could think that way, in those other ways, she was able to use those reasonings in order to think functionally even more. So I just wanted to sort of point out that hierarchy of thought that was kind of included in what we just did. All right, so if you want to know more about that, pay attention to next week's episode where we'll do one more, at least one more writing linear equations. So, if you want to learn more math and refine your mathematics teaching so that you and students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.